All right, guys, let's take a look at the last three questions on the proof worksheet from last time. All right, number 7, a little bit more complicated diagram than you guys have been working with, but at the end of the day, we're still basically trying to prove that I've got two big angles congruent, so EGF and EFG. Two big angles are congruent, and one of the parts that makes up those angles is congruent, EGH and EFJ. All right, so if one of the parts is congruent and the big angles are congruent, the other part has to be congruent. So that's what we're setting out to prove here. So first, we're gonna have to add some stuff together. So we're gonna have to add some angles together. We need to drop down from congruency to equals. So I'm gonna drop, and my first reason is gonna be definition of congruent angles. All right. After that, let's go ahead and set up our angle addition postulate so that the two small angles sum to the big angle, the two small angles sum to the big angle. All right. Since we're given that EGF and EFG are equal and congruent, we can set these two equations equal to each other. EGH plus HGF, EFJ plus JFG. All right, so because we already know these two to be congruent, we'll just set these two equations equal to each other. That's just substitution. All right. So I've got these two big long equations, and luckily I know that EGH and EFJ are equal. So some of you guys, and I wouldn't penalize you for this since you've already said these two are equal, if you just went ahead and subtracted right now, since you told me already that, all right, this guy and this guy are equal, I can see that, okay, you're subtracting the same thing from both sides, that would cancel. But just to go ahead and show it like your book does and to take it one step further, make it totally obvious, I went ahead and substituted in EGH. That way, when I subtract, it's obvious that, okay, I'm taking away the same thing from both sides so that the EGHs cancel and I'm left with just HGF and JFG. All right, those guys are equal. If they're equal, we can drop down and say they are congruent. All right, I will give you a second now if you guys want to pause it and jot that down. All right, number 8 isn't a whole lot different than number 7, except now instead of saying the two big angles are congruent, we're gonna say they're both right angles. Well, that also means they're congruent, so it's gonna be set up pretty similar. We'll say they're right angles. We'll say that right angles measure 90 degrees, so that's a slightly new reason for you guys on this. So far in this worksheet, you've seen a couple new reasons, like perpendicular lines form right angles. This one that we just used, we've used the theorem. If you are supplementary to the same angle, then you are congruent. So a couple new reasons on this worksheet. So basically we're gonna say if they're both equal to 90, then they are equal to each other, all right? So they're both equal to 90 because they're right angles. Since they both have the same measure, we can say that they're equal to each other, all right? A lot of you guys might try to skip step 4. Step 4 is important, all right? You're gonna say angle of ABD equals ABE plus CBD, and then you're gonna say angle of CBE equals measure of CBD plus angle EBD. All right, so you've got to set up this angle addition postulate. You could have kind of skipped step 3 and said they're both equal to 90, and then set this long equation equal to each other, but definitely have to have step 4. 3, a little bit optional, have to have step 4. All right. So now that I have this long equation and that these two are equal, we can set the two equations equal together to form one long equation. The key to it is that angle EBD is in both equations. So last time we said we can go one step further and substitute in. Well, this time we don't because it's EBD on both of them. You could have a reflexive here, right? We've talked about how reflexive can be a little bit trivial, but you could have a reflexive here saying EBD is equal to EBD. But we subtract EBD from both sides and we're left with ABE equals CBD. And if they're equal, we can go ahead and say they are congruent. So kind of the same setup as last one, except instead of knowing that right off the bat that the two big angles are congruent, we had to say, okay, they're both right angles, they both equal 90, thus they are equal. That's what enabled me to do that one. All right, pause it if you need to, and we will take a look at the last one. All right, number 9, when we get into triangle proofs, we could attack it a little bit differently. But the key to number 9 is eventually we're going to show 1 is congruent to 2, and if 1's congruent to 2, that's the same thing as saying F is congruent to J. So it's not quite as direct of a route as we're probably used to. All right, so we're gonna have some angle addition. So first thing we're gonna do is drop to equals because we're gonna have to add some angles at some point. So go from congruency to equal. Then I'm gonna use my other given that these two line segments are perpendicular. All right, they're perpendicular, and that's going to form some right angles for me. All right, so angle FKH and angle JKG. All right, and just like last time, not totally necessary, but if they have the same measure, then they are equal to each other. So this time, 2 questions ago, we were just given the 2 big angles were congruent. Last question, we said they're both right angles. This time, we say they're perpendicular, so we have to say they're both right angles and then say they're equal. So a little bit more steps, but you see how the kind of progression of what we've done from 7 to 8 to 9 and why 9's a little bit longer than 8 and 8's a little bit longer than 7. So now that I've got the 2 right angles are equal to each other, we can set up the angle addition postulate. Angle FKH is angle 1 plus GKH, and JKG is angle 2 plus GKH again. So same idea as last problem. If you have one of the parts in both, then the other 2 parts have to be equal. We're going to show that by setting the whole equation equal to each other. So we set the whole equation equal to each other. We subtract out the GKH. That leaves me with angle 1 is equal to angle 2. All right. This is where, if you forgot that one given, which was way back here, that we already know F is congruent to 1 and angle J is congruent to 2. That's all the way back here. But if we keep that in mind, angle 1 being equal to angle 2 is the same thing as saying F is equal to J. So if F is equal to J, then they must be congruent, and we're set to go. All right, so pause this one if you need to. I know it's a little bit longer if you need to jot that down. All right, and take a couple minutes looking over those. All right, good work, guys.